This video is for Year 11 methods. It comes out of Chapter 5 probability. It's number 6. It's one of these videos that, one of these questions that you need to work out what the question's asking and then how to sort the information. Do I use a tree diagram? Do I use a Venn diagram? Do I use a probability table? Do I use a lattice diagram? It's also one of the videos that once you've got an idea of what's going on, I think you should stop the video and then do it yourself. So hang in until you get to the point where you sort of understand. So question 6, in a knockout sporting competition, the number of rounds are played leading to the final. Only the winners from each round progress to the next stage. There are 8 teams in the local competition, 2 of which are Rangers and Knights. So I've got Rangers and Knights and 6 others. Knockout Cup is being contested. How many rounds are there in this competition, including the final? So if I've got an 8-team competition, then I would have 1 versus 2, 1 versus 2, and 3 versus 4, and 5 versus 6, and Knights versus Rangers. I'll call them 7 and 8. So that's round 1, which will get you down to 4 teams. Round 2 will get you down to 2 teams. So round 3 will be your final. So a 3-round competition. How many rounds? There's 3. Find the probability that the Knights or Rangers make the final, assuming that each team has equal chance of winning a particular match. Everyone has equal chance of winning a particular match. So I'd like to turn this around and say, if everyone's got equal chance of getting to the final, how many ways can I have finalists? So how many ways can I have finalists? I could have Rangers versus Knights, Rangers versus 1, Rangers versus 2, etc, etc, etc. And then I could count up how many had Knights in them and all Rangers in them, and I could work out that probability. Now, what's a good way to sort this? This is an example where a lattice would be a really good way of sorting. I might just prepare something. Okay, so I've drawn up a lattice diagram, all the possible first teams and all the possible second teams in the final, and since every team's got an equal chance of winning, therefore they've got an equal chance of getting to the final. Now, they can't play each other, so I can't have Knights versus Knights, Rangers versus Rangers, 1 versus 1, 2 versus 2, etc. So I can get rid of those options. This option here, which is Rangers versus Team 6, is the same as this option here, which is Rangers versus Team 6. So I can ignore these because this will just double up. So if I thought about this, Rangers could play 7 other teams. Knights could play 7 other teams. Team 1 could play 7 other teams. Since I've got 8 different teams, then there are 7 possible opponents that they could have, which is 56. However, since Rangers versus Knights and Knights versus Rangers is the same, I need to divide those by 2. So that should give me 28 possible options. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28. So that's beautiful. So how many of them involve Knights or Rangers? So 1, 2, 3, 4, 5, 6, 7, because Rangers could play 7 other teams, and then Knights could play 1, 2, 3, 4, 5, 6, because they can't play Rangers, well they can, but it's already been counted. So 13 out of 28 should be the probability of either of them getting there. Okay. In part B, drop out whenever you think you've got an idea of what's happening here. We now assume the Rangers and the Knights are 2 teams in a 16 competition. How many rounds would there be to get including the final? Well, an 8-team competition needed 3, So if we started with 16 teams, after round one we'd be left with 8, then we'd be left with 4, then we'd be left with 2. So it's going to take 4 rounds. What's the probability now of either of these teams reaching the final? Okay, I could do the same thing. Knights, Rangers 1 all the way up to 14, and Knights, Rangers 1 all the way down to 14, because that would give me my 16-team competition. However, I'd like to think about this a little bit. There were 28 outcomes because each team played everyone else. If I move over here, I've got 16 teams. If each team played everyone else, it's going to be 15, and then I divide by 2. That gives me 8 times 15, which gives me 120. There's 120 possible outcomes, and the probability that in Rangers or Knights it's going to be these first 2 rows. So I'm going to have 15 here and 14 there. So therefore 15 times Knights could play, 14 times Rangers could play, because I can't count the game against Knights because it's already been counted. So I'm thinking now it's 29 out of 120. Part C, what is the probability that the Rangers play Knights in the 8-team final? Well, there's one possibility of our 28, so that's 1 in 28. And what's the probability the Rangers plays Knights in the 16? There it is there, so that's 1 out of 120. Okay, I needed to work out what was the best way to represent the information. I chose a lattice because the lattice is really, really good when you've got lots of outcomes in a two-way event. Then I looked for patterns.